Factor the following: 3x squared minus 27x plus 60, x squared plus 10x minus 24, and x squared plus 8x plus 16. We're going to head to office assistants Brooke and Sophia to help give us a hand with this. When we are factoring a polynomial in the form x squared plus bx plus c, we factor it so that our polynomial turns into the product of two binomials. Both of our binomials are going to start with an x term, and then they are going to be adding some value that we have to determine. These two values here get multiplied together to equal the c value, but they get added together to equal the b value. It is our job to determine what are those numbers that get multiplied to get this, but added to get this. A few rules to keep in mind. It depends on what signs we have in our polynomial to determine what signs we're going to have in our binomials. So if our polynomial has two plus signs, when we factor, our binomial has two plus signs. If our original polynomial has a minus sign first and then a plus sign, our factored binomials are going to have two minus signs. So one clue that we can use to help us is if our c term is positive here, our signs are going to be the same. They're either going to be both positive because our b term has a plus sign, or they're going to be both negative because our b term has a negative. Down here, we can see if we have a plus sign and then a minus sign, we're going to have in our factored binomials a plus sign and a minus sign. If we have a minus sign and a minus sign, we are going to once again have in our factored binomials a plus sign and a minus sign. So we can use the reminder that if c is negative, if our c term has a minus sign in front of it, then we're going to have different signs. We're going to have one plus sign and one minus sign in our factored binomials. The steps that we're going to use when we factor polynomials in this format: we're going to list our factors of c, we're going to write the factors of our trinomial in this form, and then we check our work. So coming back to our original polynomials to factor, anytime we factor, the first thing we always have to look for is to determine, do we have a greatest common factor that can be pulled out of all three terms? And looking at 3x squared minus 27x plus 60, all three of these terms do share a factor of 3. If they share a factor, we pull that factor out front. So pulling that 3 out front is going to leave me here dividing by 3, just the x squared. Dividing my second term by 3 is going to leave me with minus 9x. And dividing my last term by 3 is going to leave me with plus 20. So my 3 gets pulled out front, everything else is inside parentheses. Now my job is to factor this polynomial that fits in the same model that I had on the last slide. So I need to find two numbers that multiply to give me 20, but that add to give me negative 9. So I'm going to start by listing out all the factors I can think of. The one thing I need to keep in mind though is that I'm multiplying and getting a positive, but I'm adding and getting a negative. So that means the two numbers I multiply together have to be two negative numbers. So factors of positive 20, but when I add I get negative, is negative 1 times negative 20. When I add I get negative 21, that's not negative 9. Negative 2 times negative 10 gives me positive 20, and when I add I get negative 12. That's not right. Negative 4 and negative 5, when I multiply I get positive 20. When I add I get negative 9, and that is what I need right here. So I'm going to use the two factors, negative 4 and negative 5. So I'm going to use my form, and I'm going to substitute in negative 4, negative 5. This is my factored form. Looking at another example, now I'm going to factor x squared plus 10x minus 24. I know that because I have a negative c value, when I factor, I'm going to have one positive and one negative value. So I want to list out my positive and negative values that multiply to give me negative 24, but add to give me positive 10. So I listed all my factors right here. -1 times 24, that adds to 23. 1 times -24 adds to -23. -2 times 10, or -2 times 12 multiplies to -24, but it adds to +10. And look at, that's what I needed it to add to right here. So I'm going to use a -2 and a +12. So when I substitute those into my values here, my positive is going to go here with my plus sign, and my negative goes here with my minus sign. My factored form is x plus 12 times x minus 2. My last example, x squared plus 8x plus 16. Same concept. I need two numbers that multiply to give me positive 16 and add to give me positive 8. Because when I go and put this into my factored form, since I have a plus sign and a plus sign, I know that means in my factored form I have a plus sign and a plus sign. Listing out my factors, numbers that I know that multiply to give me 16 are 1 and 16, that adds to 17. 2 times 8 gives me 16, but 2 plus 8 is 10. 4 times 4 is 16, but 4 plus 4 is 8. I want the one that adds to 8, so I'm using my 4 and 4. So I'm going to substitute 4 and 4 into my blanks. That leaves me with x plus 4 times x minus plus 4. Now in this situation, because I am multiplying the same binomial by itself 2 times, we call this a perfect square trinomial, and we rewrite this so that it becomes x plus 4 squared. So this up here is that perfect square trinomial because it factors to give me x plus 4 squared in that factored form.